Hi everyone! After the first two videos on this channel, I received a lot of great feedback from you, plenty of advice and ideas on how to improve my projects. Thank you all for that. And to my surprise, many people decided to try bringing these projects to life. And so, let me introduce the first public release of Duender, a conversion of two old Creality Ender-3 printers into a single CoreXY 3D printer. In my last video, I explained the process of developing this project, how I came up with this idea, and what goals I had in mind. This time, I'll provide a step-by-step guide on how you can build this printer yourself. And in the description below, you'll find links to all the necessary 3D models for the first release of Duender. To be honest, I'm already exhausted from assembling and disassembling this printer over and over again. During development and modifications, I had to do this dozens of times. But in the end, my laziness saved the day. Since I really didn't want to take the printer apart one more time, I decided that it's better to spend some time, or a lot of time, preparing the project for release as well as I could, so that everything can be shown directly on the 3D model. Now, besides all the printable 3D models, you can also download a step file with the complete project. It contains 99% of the information needed for assembly, including all screws, nuts, bushing, bearings, spacers and everything else. Most importantly, with this file you can easily modify the parts and adapt the project to your needs. Before we move on to the step-by-step assembly guide, let me give you a brief overview on how the project is structured. All the main printer components are organized in the separate folders. For example, in the frame folder, you'll find all the aluminum profiles needed to assemble the main frame. The component names indicate their function. 2040 post RB means it's a 2040 profile that works at the right back post. LF means left front. I think you get the idea. Next, there are folders with parts related to the Z-axis, XY-axis, extruder and the printer's electronics. Another folder contains all the kinematics components, including idler bearings, couplings, belts and spacers. Let's focus on that for a moment. While designing this project, I tried to reuse as many original printer parts as possible. However, some components still need to be bought. For the kinematic system, you'll need 20 bearings of type F623RS and two 2GT belts, 6 mm wide, about 1.5 meter long each. Then comes a folder with the old frame brackets and another one with all the necessary fasteners. There are quite a lot of them. Some can be reused from the original printers, but not all of them. In my case, I used a set containing 40 brackets, 80 M5 8mm screws and 80 T-nuts. Additionally, I had to buy some threaded inserts, regular nuts and a few extra screws. If you buy only the required parts, the total cost should be around 50 bucks. To see exactly where each screw and nut is used, you can expand the fasteners folder in the step file, and selecting specific component in the model will highlight it in the component tree. For example, to mount the lead screw nut, you'll need two M3 12mm screws and two M3 nuts. The last folder contains guides for manually cutting aluminum plates. If you watched the first video, you know that the very first version of Duender was made entirely of plastic parts, including those that held the open-built wheels. While that setup worked, plastic parts tend to deform over time under high-speed loads. That's why for this first release version I switched to aluminum plates for wheel mounting. I hand-cut these plates from 3mm aluminum using a hacksaw. If you also plan to make them manually, I've modeled special guides that help you cut and drill everything precisely. Keep in mind that the Y-axis plates require M3 tapped threads in some holes. You can check the step file to see exactly where the threads need to be made. Technically, you could print these parts from plastic, but I don't recommend it. If you have access to CNC, you can cut the necessary parts directly based on the 3D model. However, I haven't tested this method myself, so I can't guarantee that all dimensions and offsets will be perfectly accurate right away. Now let's talk about the printed parts. If your printer is well calibrated, you can print all the models without supports. All the main parts that need to be printed are marked in blue. You'll also need to print spacers for the bearings, which are marked in white. A full list of required printed parts is included in the project. For materials, I recommend using something high temperature resistant, ABS or better. If you don't plan to enclose the printer in a heated chamber, PETG or even PLA might work for some parts, as long as they are not exposed to the heat from motors, extruder or heated bed. For print settings I used 4-5 walls and 5-7 top and bottom layers for all moving parts. Infill was set to gyroid at 50%. For stationary parts the same settings should provide enough strength, but if you have the time and filament, printing with near 100% infill is always a good idea. Extra strength never hurts. Now let's move on to assembly. All the profiles are connected using metal corner brackets with T-nuts inside the profiles. There are many ways to joint aluminum extrusions, but I choose brackets because the profiles on budget printers are often not perfectly cut, and brackets help compensate for these imperfections. I can't give you exact step-by-step sequence for assembling the frame so that it comes out perfectly square. The key is to tighten all the screws gradually, constantly checking for parallel alignment and diagonals. It's an annoying process, but extremely important. It's better to take your time at this stage to avoid issues later. The base of the frame is a rectangle made from 4 40-40 profiles, which were originally the legs on the Ender-3 printers. The front and back profiles should extend by 20 mm to leave space at the corners for the vertical posts. The base is secured with the 8 brackets from the inside. Of course, all necessary T-nuts should be inserted into the profiles in advance. Once assembled, adding and removing T-nuts becomes very difficult. To check and count how many nuts are needed in each profile before assembly, you can make only the frame profiles and T-nuts visible in the step file and count them. If needed, you can use drop-in T-nuts, which can be inserted into the profile later without access from the ends. From here on, I won't mention exactly where and how many brackets I used, since you can always check this in the project file. The vertical posts are 4 longest 2040 profiles from the Ender-3s. They were originally the printer uprights, and their lengths allow us to keep the full print height. These posts are also attached to the base using brackets. Pay attention to the position of the holes on the back left profile. It must be installed exactly as shown in the project, because later the power supply will be mounted to it. The next step is installing the profiles that will work as the Y-axis guides. For this I used the same profiles that were originally used for the Ender-3 bed movement. And here we come to the most frequently asked question in the comments under the first video. Can this project be built using other versions of the Ender-3 or with Ender clones from other manufacturers? Only the very first version of Ender-3 used 2040 profiles for the bed movement. In all later versions, as well as in most Ender clones, this profile was replaced with 4040. In my configuration, I used the narrow side of the profile for the wheel carriages. The profile itself is shifted toward the outer wall to avoid losing build volume. Can you replace this with the 4040 profile instead? I think yes, but with some complications. In this version, which use open-built wheels, you would need to make the carriages wider to position the wheels 20 mm farther apart. This would increase the size and weight of the carriages, limiting the maximum printing speeds. If you plan to switch to rails later, replacing these profiles with 4040 won't require any major changes. But in this open-built version, using 4040 profiles could cause issues. If necessary, you can buy two 2040 profiles 330 mm long, or you might already have similar profiles laying around. With the bad-slingers that are not direct Ender clones and have significant design differences, things get more complicated. We'll discuss this at the end of this video, but for now, let's get back to assembly. At the back I used a 2020 profile as a crossbeam. It was originally the top bar of one of the Ender-3s. You may have also noticed that my printer has an additional 2020 profile mounted at the front. This one doesn't come from the two Enders. It's optional but highly recommended. It reinforces the frame by closing it at the front, and also helps align everything if the original profiles weren't perfectly cut. Theoretically, you could replace this with a 3D printed part. or use two oddly shaped leftover profiles from the original printers. Now let's move on to assembly the Z-axis. This is where you'll notice the first major change. I've moved the profiles inward and lowered the motors. This change made the walls almost flat, making it easier to enclose the printer later if needed. The first step is assembling the wheel carriages. The big holes are for wheels with eccentric nuts. The small ones are for regular wheels. The aluminum plates with wheels need to be attached to the plastic part using 4 screws with nuts. Optionally, you can glue these parts together for extra strength. You also need to attach the lead screw nuts to the plastic parts. Next, install the motor assemblies and the 2020 profiles that were originally the Ender-3 X-axis onto the printed mounts. An important note: if you watched my previous video, you might remember that I had to cut the lead screws because they didn't fit. When I redesigned the Z-axis, I moved the motors inward and lowered them, hoping that the original screw would now be the right length. But unfortunately, even in this configuration, the screws still slightly too long. In theory, you could mount the printer on the feet and lower the motors even more. If you want to do that, you can easily modify the project. But in this configuration, the lead screw needs to be shortened by about 10 to 15 millimeters. Once the motors and profiles are installed, you can slide on the wheel carriages and adjust the eccentric nut to ensure all wheels press evenly against the profiles. The wheels should rotate smoothly with a slight resistance when turned by hand. The complete assemblies can now be installed inside the printer. Secure them from the bottom with the M5 8mm screws into the T-nuts in the lower profiles and fix them from the top using the plastic part with the 2 screws. The distance from the front vertical post to the Z-axis profile can be adjusted to avoid losing print volume. This may depend on your extruder setup. In my case, they are mounted 97mm from the front post. You can measure and align these profiles using caliper. The next step is installing the X and Y axis. Some parts need to be screwed directly into the profile ends. These profiles have holes, but they need to be tapped with the M5 threads. There are 8 such locations. If you don't have a proper tool, you can slowly screw in a steel bolt while adding a little oil. It's a bit tricky and risky, but possible. This is how I tapped all my threads. Next, install the XY motor mounts. Each of these parts needs 5 M3 threaded inserts melted in. The best motors for the XY axis are the extruder motors from the original printers, since they are most powerful. But you'll need to swap the pulleys. On the earliest Ender-3 versions, Creality used normal removable pulleys, which are easy to unscrew and reinstall as shown in the project. One is mounted normally, second is flipped upside down. But in the later Ender-3 models, the X and Y motors came with the press-fit pulleys. They are harder to remove, but it's still possible with a special printed tool. When installing them, make sure they are at different heights, so they align with the belts. Mount the motors with the pulleys on the brackets, then secure the brackets on the frame with the 3 screws. Now prepare the idler assemblies for the back mounts. The correct order of bearings and spacers on the M3 30mm screws can be seen in the project file. Once assembled, carefully install them onto the mounts and tighten the screws. They should be snug but still allow the bearings to spin freely. The next step is assembling the X-axis carriages. First, attach all the wheels to the aluminum plates, then prepare the bearing assemblies and screw them into the plates. The screws in this location go directly into the threaded holes in the plates. Once assembled, you can install the carriages onto the frame and adjust the bearings. Now install the X-axis profile. This is the 2020 profile that was originally the Ender-3's top crossbeam. It needs to be cut to 300 mm. I also drilled a lot of holes in this profile to reduce weight, but honestly I don't think it made much difference. Install the profile with the prepared T-nuts onto the carriages and screw it in from the bottom and back. At this stage it's very important to align the X-axis profile as straight as possible. To do this, press the entire structure against the back wall and tighten the screws while the axis is properly aligned. Now you can install the front mounts for the belt tensioners. The left side is for the lower belt and the right side for the upper belt. Insert an M5 nut into the back of each tensioner, melt in the threaded insert at the bottom, and install the bearing assemblies with the spacers. After that, slide the tensioners into the mounts and secure them with the M8 30mm screws. Finally, before we can install the belts, we need to mount the extruder. As you may have noticed, I've been using a custom extruder on my printer for a while now. It's based on the Big U H2 extruder but with the hot end from the Bambulab P1P. However, it's not ready for release yet. The problem is that I used gears from one of the early H2 extruders, and they are slightly different from the ones in the later versions. So for this version of Duender I decided to use a standard H2 extruder, but this is more like an example. Theoretically, you can use almost any extruder that fits in this space. The main requirement is that it should be as narrow as possible along the x-axis, otherwise you will lose print area. The original Ender-3 extruder might work with the minimal modifications, but I don't recommend using a Bowden setup. The stock hot end is also outdated and inefficient, so it's best to replace it. But most likely your old Ender-3 already has a different extruder installed. This specific setup with the H2 is not the most optimal. With it you lose about 2 cm along the x-axis, but it allows me to show you a mounting method that you can adapt for your own needs. First, you need to modify the wheel plate. One option is to create a completely new plate using the guides, just like other plates in the build. That's what I ended up doing for my own printer. But you can also use the original Ender-3 plate and simply drill a few extra holes using the guides. The trickiest part is making the belt attachment slots. To do this, drill several holes and carefully connect them with the file. To mount H2 extruder you only need 2 holes, 50mm apart. The small metal tabs that originally held the Ender-3 belt should be cut off or slightly bent out of the way so they don't interfere with the carriage movement. Next, attach the wheels to the plate. A printed part is placed in the front of the plate to create a flat surface, and then the extruder is mounted on top of it. The whole assembly is secured with the 2 M3 12mm screws from the back. To install the carriage onto the profile, loosen the 2 top wheels, place the carriage and then tighten the wheels back in place. As for part cooling, the setup I'm using is just an example, you can use a different one. I chose this design because it's compact and doesn't interfere with the extruder movements. However, it's not the most efficient solution. Now we can install the belts. The correct belt routing through the pulleys and motors can be seen in the project file. One important note: compared to previous versions, the belts are now flipped so that the teeth face forward. I did this to match most modern CoreXY printers. In this configuration, the belts are only pressed against 2 pulleys with the teeth. The rest of the pulleys are contacted with the smooth side of the belts. Theoretically, this should reduce belt vibrations and, as a result, minimize VFA. But we won't dive into that topic in this video, it's already long enough as it is. The belts should be secured to the carriages using zip ties. After that, you can tighten them by turning the screws on the front mounts. Belt tensioning on the CoreXY printer is an art in itself. First, both belts must be exactly the same length. Second, the tension must be identical or the x-axis will be misaligned. Third, they should be not too loose and not too tight. I realize this doesn't sound very precise or scientific, but without a special measuring tool I can't tell you the exact optimal tension. The goal is to have enough tension to prevent belt vibrations, while still allowing the axis to move freely. To check if both belts have the same tension, you can use a simple 3D printed tool. Now let's move on to the electronics. The power supply can be mounted to the back left vertical post. The screen is easily installed on the base front profile. At the back of the printer I placed the electronic enclosure. I designed this enclosure for my specific setup. On the left I have a big Tritec E3 RRF board, simply because it was the fastest board I have available at that time. This board had the same mounting holes as the original Ender-3 board, so you can install any upgrade board designed for the Ender-3. There are plenty of options on the market. Most likely at least one of your old Ender-3s already has a proper 32-bit board with the silent drivers. On the right, I installed the Big3Tech CB1 with the PI4B board. Here you can install an original Raspberry Pi or any compatible alternative with the same mounting holes. My printer runs on Clipper firmware. Yes, it can work with the Marlin or even on the stock Ender-3 board, but there is not much point in doing that. I haven't used Marlin for years, and if you are still on it, I highly recommend switching to Clipper. It's way faster, more convenient, and far more powerful. I won't go into the details of installing and configuring Clipper in this video. I'll share my configuration files along with the project. If you already know how to set up Clipper, it should be easy to adapt my config to your board. There are just a few important things to note. All the stepper drivers on this board run in UART mode. This means that motor current, microsteps, and all other settings controlled directly from the configuration file. For sensorless homing, I use tall detection for the X and Y axis. If you prefer, you can connect physical end stops and mount them somewhere on the frame. However, in my setup, I try to minimize unnecessary wiring. For Z-homing and automatic bed leveling, I use a BL Touch. There are better sensors out there, but this is the one I already had. The axis has two motors, but they are wired in parallel to the single driver, and they just move together, but they don't have independent synchronization. So sometimes you may need to manually level the bed by pushing the carriages against the top profiles. If your board only has one Z-motor connector, you can use special adapter or make parallel custom cable yourself. So, what if you don't know how to set up Clipper for your printer? Option 1, you can try to figure it out by yourself. There are plenty of tutorials on YouTube. Once you understand the basics, you can use my config as a reference and adapt it to your setup. Option 2, you can wait for me to release a dedicated video on installing and configuring Clipper. And one last thing. Many people have asked whether this conversion is possible with the other bad-slingers that have different frame designs, such as Teva Tornado or Creality CR10. I'm almost sure that any two bad-slingers built on standard V-slot aluminum profiles should have enough parts to assemble a CoreXY printer. In some cases, you might even end up with the extra parts. It's also very likely that XY kinematics from Duender can be used almost unchanged. However, the Z-axis will probably need a complete redesign. You can try adding profiles from your own printers to my project and see if you can assemble a frame that fits the Duender parts. Okay, that's it for now. The video is already way too long. I tried to give you as much useful information as possible. Hopefully it's enough for you to build your own Duender. This project is completely open source and you're free to modify and improve it however you like. I hope you find this video useful. As always, like, comment, subscribe. If you'd like to support this channel financially, you'll find all the links in the description below. And that's all for today. See you soon!